For decades, astronomers have suspected that something lies hidden in the outer regions of the solar system. Beyond Neptune, where the sun is just a faint point of light, a previously undiscovered planet could be orbiting. The hypothetical celestial body is known as Planet 9, and its existence could explain why certain Trans-Neptunian objects in the Kuiper Belt and beyond move so strangely. Despite numerous investigations, Planet 9 has so far eluded our gaze. But now, a new study could finally provide a groundbreaking clue. A recent analysis of 2 research missions conducted over a period of more than 20 years has revealed a faint signal that has shifted slightly over time. This is exactly what one would expect from a distant, slowly moving celestial body. And if the finding is confirmed, it would be an absolute milestone for astronomy. But what exactly have the experts detected in the depths of our home world? What argue for the existence of Planet 9 and what against it? Stay tuned until the end and find out with us. The idea that an undiscovered planet lies beyond Neptune is by no means new. In fact, astronomers were searching for additional planets over 100 years ago to explain strange deviations in the orbits of Uranus and Neptune. At the beginning of the 20th century, theoretical considerations led to a targeted search and ultimately to a sensational discovery. And yet the bottom line was that Pluto, discovered in 1930, was simply too small to cause the observed anomalies. As we know, Pluto has since been removed from the list of official planets. But the search for an unknown world continues. In recent years, Trans-Neptunian Objects, or TNOs for short, have become the focus of research. These include icy worlds such as Sedna or 2012 EP1113, which have astonished experts with their unexpected movements. Their orbits are strikingly similar in orientation, and one might think that the objects are influenced by a powerful but hitherto invisible force. In 2016, astronomers Konstantin Batygin and Mike Brown substantiated this assumption in the course of a detailed analysis. They examined the orbits of several TNOs and confirmed the similar orientation of the objects. However, since a purely random constellation of this kind is statistically extremely unlikely, another explanation was needed. And the most plausible one ultimately lay in the effect of a large planet about 5 to 10 times more massive than Earth orbiting in an eccentric orbit between 400 and 800 astronomical units from the Sun. And once again, briefly for context, the length of an astronomical unit corresponds to the average distance between the Sun and Earth, which is about 150 million kilometers. And while our earthly home is known to take 365 days to complete one orbit around our host star, Planet 9 would take several millennia to accomplish this. A planet of this size and distance could significantly influence the orbits of TNOs with its gravitational pull. This constant invisible force would keep the orbits of distant objects stable in certain directions over a long period of time, almost as if they were guided by an invisible guardrail system. Okay, so far so good, but also so theoretical. Because although Planet 9 is capable of providing coherent explanation for the observed phenomena on paper, its actual existence has not yet been confirmed. But why is that? How is it that the James Webb telescopes of our time are looking deeper than ever into the oldest mysteries of the universe, and yet we are unable to detect a planet on our doorstep? Well, this is primarily due to its remote location. If it really exists, Planet 9 receives only about 0.01% of the sunlight that we get on Earth. This means that it would be virtually invisible in visible light. But that's not all. Such a distant planet would also move very slowly across the sky, which means that normal surveys would not only be confronted with a light problem, but also with observation periods that are far too short to detect such a slow movement. A new lead. What Iris and Akari have discovered. But what does this tricky situation actually mean? Against this backdrop, will it ever be possible for us to add Planet 9 to the space maps? Fortunately, that is not the case. Quite the contrary. In fact, because a re-evaluation of data from 2 research missions has now revealed a groundbreaking detail. But more on that in a moment. To get around the problem of optical telescopes, experts hunting for planets are relying on infrared observations. These do not rely on reflected sunlight. Instead, they register the thermal radiation of the celestial body itself. Even after billions of years, a large planet still emits enough residual heat to be measurable in the right wavelengths. This makes infrared data particularly valuable for the search for distant cold planetary worlds. But the astronomical view back in time should not be underestimated either. Instead of just conducting new observations, researchers also evaluated data from two space telescopes, IRIS, which was launched into space in 1983, and ARI, which followed in 2006. There were more than 20 years between these two missions, and that is precisely the crucial point. After all, this period of time makes it possible to detect the slow movement of distant objects. To do this, scientists track how an object shifts over the years in comparison to distant background stars. This allows even tiny movements to be detected and celestial bodies to be identified that would be completely inconspicuous in short observation periods. Using simulations and models that took into account the brightness, temperature, and expected movement of a hypothetical planet, a team led by astronomer Terry Long-Fan from National Tsinghua University in Taiwan was able to sift through thousands of infrared signals. Through careful filtering, they narrowed down the number of possible planet candidates to just a few objects and discovered something absolutely remarkable. One of the objects showed all the characteristics that would be expected of Planet 9. The right brightness, plausible movement during the IRIS and ARI missions, and no trace during observation periods when it should have been visible. Have we found Planet 9? What information another discovery provides? The promising candidate from the IRIS and ARI data could indeed be the long-sought Planet 9. Although in this case the emphasis really is on the word could, it's still completely unclear what has appeared in the data. Theoretically, it could really be the planet of desire, an imposing celestial body with 5 to 10 times the mass of Earth orbiting at a distance of between 400 and 800 astronomical units. However, we could also have caught a large trans-Neptunian object or even a brown dwarf which only has planet-like properties. Another possibility is that we are dealing with a rogue planet that originally formed outside our solar system and was only later captured by the gravity of our host star. To finally uncover the identity of the candidate, Fan and his team proposed to examine it in the future with a dark energy camera at the Cerro Tolo Inter-American Observatory in Chile. This instrument can capture very faint light and simultaneously observe a large area of the sky, which could detect even distant, slowly moving objects such as Planet 9. However, this only applies if Planet 9 actually exists. But unfortunately, this idea is once again being questioned as a result of another exciting discovery. But first things first. A few weeks ago, astronomers detected a new dwarf planet in the outer solar system, named 2017 OF201. This small but impressive cousin of Pluto has a diameter of around 700 kilometers, and while its closest point to the Sun is about 44.5 astronomical units, its furthest point from the Sun takes it more than 1,600 times further away from our host star than Earth. As a result, the dwarf planet takes around 25,000 years to complete one full orbit. But fortunately, at the time of its discovery, it was close enough to our home planet to be captured by the dark energy camera. In fact, the object spends less than 1% of its time in regions that can be observed with our telescopes. But what does all this have to do with Planet 9? Well, quite a lot. Although only around 5,000 Trans-Neptunian objects are known to exist in the Kuiper Belt beyond Neptune, their orbit, as mentioned above, show a striking alignment that suggests the influence of a massive planet. But the new dwarf planet breaks this pattern. While the eccentric orbits of many TNOs are often around 60 degrees, the perihelion alignment of the cosmic newcomer is 306 degrees, and that is quite problematic for the possible existence of Planet 9. Model calculations have shown that the dwarf planet's orbit will remain stable for at least 1 billion years even without the planetary phantom. And if Planet 9 is now added in its presumed form, the picture changes dramatically. It would influence the object's orbit in such a way that it would eventually come too close to Neptune and be catapulted out of the solar system after about 100,000 years. But does that mean conversely that the existence of Planet 9 can be categorically ruled out? Well, it's not quite that definitive. But the probability of a Neptunized 9th planet in this part of the solar system has been significantly reduced. And so it remains that Planet 9 remains a mystery, at least for now. And only the future can tell whether we will one day shed light on the outer solar system. And if you click on our subscribe system now, you'll never miss a new video from us again. So go ahead and click on the thumbs up and subscribe buttons to stay up to date from now on. See you soon.